Hello everybody, and welcome to your first lecture for Unit 6. Unit 6 being energy resources in the context of environmental science. Alright, with this particular set of notes we're going to differentiate between renewable and non-renewable resources. We'll look at global energy consumption and distribution of natural energy resources. The big idea is understanding that there are positive and negative consequences from how humans use energy in its variety of forms. And let's please read from Chapter 14 of the Miller textbook, Section 14.1, pages 420 to 422. All right. So first of all, when we talk about energy usage in the context of this course, we're talking about energy required for things like electricity, so to power your home devices, your lights, your computer, television, washing machine, dryer, dishwasher, etc. All right. We also use a significant amount of energy for the purpose of transportation, so to propel your vehicle. All right. Typically a liquid fuel in the form of gasoline or diesel, although increasingly coming from electric resources. Now, heating and cooking can and often is done through electricity as well. Although a lot of homes are equipped to do those particular applications through things like natural gas or propane. All right. And then, of course, we have lots of industrial processes that require large inputs of energy. Okay. So in the context of this course, when we talk about energy, we're talking about energy needed for these particular purposes. And what we want to look into right now is what types of resources provide this energy. Historically, presently, and likely in the future. And then where are these energy resources located? All right. So first of all, let's differentiate between renewable and non-renewable. And I want you guys to think of this as a spectrum. All right? Because some resources are not necessarily entirely renewable or entirely non-renewable, but it is sort of a spectrum. Where on one side, perhaps we have a resource that's completely inexhaustible, and on the other side of that spectrum is there's no way to get more of it. And we have a fixed quantity that there will never be more of. So things we might consider inexhaustible would be things like solar and wind. And the reason we're calling those inexhaustible is that however much we tap into today, right? So the amount of solar energy that we use today, for example, has no bearing on how much energy we're going to get from the sun tomorrow. And that photovoltaic panels and wind both being solar-driven energies, there is not a way to run out, right? Because we're not impacting how much energy the sun sends to us based on how much of that we organize into electrical energy. Okay? Now, if we compare that to something like hydropower, so hydropower is a renewable form of energy in that we send water over that dam to produce electricity, for example, and that water heads downstream eventually to the ocean. There is the water cycle that will eventually return water back up to the top side of that dam. So that's a renewable process, but it's not quite as immediate as like the return of sunlight every day. All right, and so it is possible to use that hydropower resource faster than it is replenished through the water cycle. So yes, renewable, but not inexhaustible. Okay, and then on the non-renewable side, we've got things like fossil fuels, where theoretically, because they are the remains of partially decayed and compacted and heated plants over time, plants exist today. Theoretically, we could make more oil or more natural gas or perhaps even more coal from those. It's just that process is so insanely slow, right, that we're using the fossil fuels probably more than 1 million times faster than they even could be replenished if the conditions even exist for them to be recreated in the first place. All right. Likewise with things like nuclear fuels, uranium, for example, is a metallic mineral, right? It's more or less a fixed quantity. There's no processes to create more of them. Now, there might be a lot of fossil fuels in the ground still, a lot of uranium in the ground still, but it's not renewable in the sense that our natural biogeochemical cycles are not going to produce more of them. All right. Now, where are we getting our energy from currently? So globally and right here in the United States, approximately 90% of our energy comes from non-renewable resources. So we have a big obstacle to overcome in terms of sustainability. As long as we're defining sustainability as being able to rely on Earth's natural cycles to provide and replenish what we need, by nature, non-renewable resources, nature is not able to replenish and provide what we need indefinitely. Okay, so 90% of our energy are non-renewable, unsustainable resources. And of course, as you guys probably already knew, that comes from natural gas, coal, and oil, or fossil fuels. We do have a certain percentage that comes from nuclear power, and 10% comes from renewable resources, including hydropower. All right, it is worth stating, though, that the quantity that we get from our renewable resources is increasing over time at a fairly rapid rate. So we can look at this a little more graphically, where we can see a historical perspective of where we were getting most of our energy. So prior to 1850, most of our energy came from biomass, mostly wood. All right. Coal, for a long period of time, has been a large provider of our global energy. Early 20th century, mid-1900s, we started seeing oil as a very, very valuable resource, and it's still one of our biggest overall producers of energy. Natural gas is really taking off as a big chunk, but notice that those renewables are beginning to take up a larger share. Now, as we fast forward farther into the future, we can do some projecting. Where do we think we'll be getting our energy from in the future? And notice that renewable sector is going to eventually, sometime around 2050, be our largest provider of energy. Also notice that our overall energy production and requirements are going to increase pretty significantly. And so we still have a large share coming from our petroleum or oil, natural gas, and coal. Right? That is problematic, by the way. We'll get to that a little bit later. All right. Now, as you guys know, because we have talked about this in several other units, the consumption of energy is not even. Right? Our highly developed countries, like the United States and most of the European Union, consume a lot more energy per capita or per person than our less developed countries. Okay, so again, remember that term is talking about the per person energy usage. All right, so in the U.S., we're only 5% of the global population, but because we have a high per capita energy consumption, we consume about 25% of global energy production. All right, so we can factor in the total energy requirements, the total energy footprint. There's two primary variables. One, we have to consider the per person energy usage, but also the total size of that population. So the U.S., for example, we do not have the highest energy consumption or per capita energy consumption. Places like Iceland actually have significantly higher per capita energy consumption. But we have kind of the double whammy of having a pretty high per capita and a very high total population, which makes our total energy footprint pretty large. Now you could take somewhere like China, which has an enormous population, right? And compared to the U.S., they lower per capita. But because our population is so much larger than the U.S., their total energy footprint is in fact larger than the U.S. total energy footprint, particularly as they are industrializing. So let's go back one slide again. You'll notice that the U.S. and the European Union, the per capita energy consumption is in fact decreased over time. Part of that comes from better efforts in and around conservation and efficiency. Right? But notice places like China, there's a big increase in per capita consumption. And that is because China is going through the development process. People are enjoying a higher standard of living and therefore having a larger demand for energy. All right. As it goes through the full industrialization process, you would expect them to follow a similar pattern to the United States and the European Union. All right. Now, where are we getting our energy from? It is worth knowing where our energy resources are located in general around the world. So if we look at oil resources, for example, of course, Middle East countries, Persian Gulf countries, right? Saudi Arabia, Iran, Iraq, United Arab Emirates. Venezuela has really high reserves. Russia, China, United States, Canada, Mexico. Okay? But Persian Gulf countries, Venezuela are the two biggest oil capitals of the world, I guess you could say. All right. Now moving on to natural gas. We'll notice that Russia, and then again Iran, Qatar, Saudi Arabia, again are Persian Gulf countries. Part of the reason Persian Gulf country will notice, I should say, not just in the Persian Gulf, that our countries with a lot of oil also tend to have a lot of natural gas. That's because they form under similar geologic conditions, and they're often found side by side. All right. But notice that Russia, Iran, Qatar, Saudi Arabia, Persian Gulf countries, United States, highest natural gas resources. They're also among our highest oil resources. All right. And then moving on to coal. This is where the United States presently has the highest overall reserves, proven reserves. Okay. But again, notice Russia, China, a lot of these countries end up with really high reserves as well. So part of the lesson I want you guys to kind of get from this is, yes, it is worthwhile to know, like, you know, which countries have the most coal, which have the most oil, which have the most natural gas. But it's important to point out that there are very much fossil fuel rich countries. And a lot of that, well, it's entirely due to their geologic past. There are conditions, right, that created these fossil fuel reserves underground that were more prominent in certain parts of the world than others. Climate and geologic history have a lot to do with that. Okay, we do want to recognize that certain countries are very much energy resource rich, and other countries are going to have to rely heavily on importing those energy technologies because they just don't have that natural resource available to them where they are. Japan, for example, very high standard of living. They have to import much of their energy from other parts of the world. All right. Now, it is worth bringing up uranium here as well. So uranium is the fuel we use for nuclear power. And notice that Australia has the highest reserves there. All right. That brings us to the end. We'll discuss this a little bit more in class. But make sure you guys follow up with the reading. And again, the big takeaways are being able to differentiate between renewable and non-renewable resources, understanding what types of resources provide our energy. So fossil fuels being the largest contributor. 90% of our global energy production right now comes from those non-renewable resources, although renewables are increasing in their proportion over time. Okay, and then also that you know more or less where are our most energy resource rich parts of the world when it comes to fossil fuels, Persian Gulf countries, Russia, North America, all right, etc. All right, we'll talk to you next time.